Professor Hargopal, you can switch on your camera if you wish, or keep it closed. It's up to you.
Yeah. I'll switch.
So we are online,
Yeah.
and I welcome you all to the second day of our short-term course on research methodologies in science. Today we have in the first session Professor Hargopal. Professor Hargopal presently is Professor of Statistics at the Department of Mathematics, BITS Pilani, Hyderabad campus. He is a retired professor and former head Department of Statistics.
Najam sir, you can make everybody mute.
Yes, there's some crosstalk there. So Professor Hargopal is a former head of Department of Statistics, Usmania University, Hyderabad. He has been the chairman board of studies in statistics for 3 terms. He is the former director of Center of Quantitative Methods, Usmania University. He is the former coordinator UGC DRS SAP 1 and SAP 2 and instrumental in getting 1 crore to the department. Professor Hargopal got his PhD from Usmania University, and he's working for he's on membership in various scientific institutions, in various pharmaceutical companies like Aurobindo Pharma. He's a consultant cum mentor to SPSS Inc., which is a statistical package for social sciences, and not just social, it's used even for sciences very efficiently. He's a former president and life member of AP Society of Mathematical Sciences, life member of AP's Academy of Science, life member of Society of Development of Statistics, and life member of Indian Society of Probability and Statistics. He's on editorial boards of various journals. So with this, I will stop his short introduction and hand over to Professor Hargopal. Thank you for being with us, sir. You'll have to unmute.
Yeah, thank you, Professor Hassan, for introducing me to the participants. So welcome back all the participants to this particular, it's actually a training on research methodology. So which is really, it will be quite useful, those who are doing research and those who wants to handle some projects. So this will be quite useful. So I request you all to take 100% involvement, and then also unmute yourself, and then don't keep it to yourself, the questions and the doubts. So you can as well clarify with me one by one. So no problem as such. Right? So just coming back to the actual this thing here. So when you just go for any data collection, so you are seeing this particular questionnaire, and here this questionnaire is having what actually it is having. Various questions here, right?
We are seeing your PowerPoint presentation and not in the presentation mode. We are unable to see.
Okay.
I'm sorry to interrupt.
No, it's all right. Yeah. So now I hope you're seeing it here. Yeah. So this is actually a questionnaire. So this is the instrument, and then with which people collect data, and then this is actually, I hope it is visible on my screen.
It's fine now.
No, it's fine now. Okay. So this is actually the titled as multi-sensory marketing marketing in hospitality sector, a study of select hotels. So this is actually a questionnaire which is done here. So we are not bothered about the consistency of this particular questionnaire, but we are bothered about the data which we collect. So coming back to this here, so name is actually a string variable. Then gender, you have 2 types of gender. So nowadays people go for the other thing also, but anyhow, so this is taken as on a male and female. Then age is there, so below 20, and then 20 to 29, and 30 to 39, etc. So this is here actually this is actually categorization of the age groups are being taken. So one disadvantage in this particular case is that here actual age could have been a very better aspect than the categorization. If you have an actual age, you can as well categorize your data collected. So that is the disadvantage of this particular question area, right? So then marital status is single, and then married, and then education is intermediate, graduate, and postgraduate. Then occupation is student, homemaker, business, employed in public sector, etc. So these are the various questions which we have seen it here, right? So these are the questions which you have here. So there are 9 questions which are given here, and similarly here even this is also a disadvantage. So actual income could have aspect, but the researcher has put it as categorization, right? So given this particular data, so how do I analyze this? So my ultimate goal is that here analysis, and then what is the pattern of evaluation can be seen from this particular data, right? So for involving yourself in data analysis for this particular data, part 1 data, so then first of all, you should know that here what sort of a data you are using it, right? So what is the type of data you are using it here? So if you just take it here, gender is actually, I say male equals to 1 and female equals to 2, and age categorization is being taken into 1, 2, 3, and 4, and 5, and 6. So 6 age categorizations are being given here. So 1 to 6 it will be. Marital status is 1 and 2. So like that, I'll be coding this particular data, and then with this code values only the analysis is being done through the SPSS or through R or any other this thing here. So it could be a Statistica or Minitab or MATLAB or whatever you want to, you can as well do that here, right? So now, the question is that here, my interest here is as a statistician is that here, what sort of a data I am using it here in part 1? Anyone? What is the data type we are using it here? Is it actually a numeric data, or is it a continuous data, or is it actually a discrete data, or is it actually a qualitative data? What sort of a data it is? You can unmute and then answer. What sort of a data it is?
In chat, someone has put in
Chat.
say numeric data. Rabia Tehseen says numeric data.
No, I'm not seeing the chat. Okay. So anyhow, so that is, that is wrong actually.
Discrete, one writes discrete. Priya Hassan says discrete and qualitative, Arjun Das.
Yeah. So it is actually, where is this chat here? I'm used to Google Meet. Which uses Google Meet. So this
right
is new
below, and you have this next.
More is there.
Yeah, more.
Chat.
If you click that, you'll see a chat.
Yeah.
Click it appears.
Yeah, correct. Yeah, good morning. Yeah. So numerical data, discrete and qualitative data, and discrete. No. So this is actually, it has got a, model. Actually, what sort of a, it is not discrete data only, but how do I justify that? Yeah, this is discrete data, right? So that is the thing which you have to do. So actually here, when you just say that here, this is male and female is actually a nominal data. It is, right? This is actually a nominal data, right? This is not continuous data, as someone said that here it is discrete data only. So how do you justify this is discrete? So what is the difference between a continuous data and a discrete data? So, and then, so these things are really essential for analytics here. For instance, if I say male is 1 and female is 2, so I have data on 1 and 2, 1 and 2, 1 and 2. So all people give I give, I'm a male, and then a female will give, she's a female, and then 2, she will give. So like that, it goes on, right? When it goes on, I mean, you have only a column of gender, and then where you have male and female. So then what sort of analysis I can do? One simple thing is that here I can as well calculate the frequencies. So how many males are there and how many females are there? Suppose if females are dominating than males, I'll say that here it is actually a female dominating survey, right? So this conclusion I can as well make it here. So next thing is that here I want to talk about descriptive statistics here. So people go a little further, and then they want to calculate this thing here. What do you call it? Suppose if I say descriptive statistics, you can as well calculate mean, median, mode, and standard deviation, variance, etc., range, etc., etc. So the many things you can as well calculate. But definitely, when I say gender, I cannot calculate the average. So because the average value turns out to be 1.5, because it is 1 and 2, 1 and 2, neither it belongs to a male or a female for conclusion purposes. So nominal data cannot be calculated, the averages and standard deviation. So that is actually a wrong thing if one has to. People are publishing articles with the gender as the average as 1.2. So that means what actually they don't know what is the data type they are using it. Simply the package, whatever you just feed into the particular package and get the descriptive statistics calculated. So that is wrong. So this is the basic mistake people do. So that's the reason I have just taken up the first lecture under research methodology is the data type. And also most of you doesn't know what is actually the differences between the discrete data and continuous data. And also most of you doesn't know that here what sort of analytics can be evaluated for discrete and as well as continuous data. So this is my agenda today. In the first lecture, I will be talking about the data visualizations. Data visualization is nothing but here. So which data has to be fit for histograms, and which data is fit for a cluster bar chart, which data is fit for a pie diagram, and then do the analytics here. And so if you just see this particular questionnaire, so the questionnaire which you have taken, most of you have answered correctly, that's a qualitative data. So definitely qualitative data. So qualitative data is being divided into 2 sets of data types. One is called as the nominal data. The other one is the ordinal data. So if you just see this here everything is nominal. 1 to 9 questions, I just get only the nominal data. So that here nominal data doesn't have the any preferences. But if you just go to this particular aspect here, if you just go to the below here, part 2 of this thing here, questionnaire. So here I say, please rank the factors that influence your selection of a hotel. Past experience on a 5-point Likert scale. 1 is least important, 5 is most important. So this is called as the ordinal data, right? So after identifying this thing here, so you have to say that here, what are the type of data I use, and then after identifying the data type, I can as well do a proper statistical test for this particular data collected. So that is the context with which we collect data. So data can be collected by 2 ways. One is primary data collection, and the other one is the secondary data collection. So primary data, you are the person who will definitely collect the data through this particular instrument. The instrument is the questionnaire, and then the reliability of this particular questionnaire should also be measured. Why? Because suppose if the questions are very haphazardly done, reliability will be very low. So if there is so reliability is nothing but what actually relationship. So the flow of the questions are proper, then answers are also given in a proper manner. So that sort of this thing is called as Cronbach alpha. We'll use Cronbach alpha or Gutman, or there are many methods, split half. So there are many methods with which you can as well see the reliability of that particular data, right? So the next thing is that here, this is actually a single question. So which single question has got what actually influence influence of you selecting this particular hotel. So there are 13 sub questions which are given here. So what sort of analysis I can do? So this is actually a multivariate data. On a single question, there are multi variables are being tested. So from 1 to 13. So when you have this type of data, so this is actually ordinal data. It will be between 1 and 5. What sort of analysis I can do? So these are the things which we want to study here, right? So then I just go to my presentation. So this is the background with which we'll do this thing here, right? So now this is the thing which I talk about. So that is the data types. So I mean there are types of data. So in this you have categorical data and measurement data. So you someone has said that your categorical is nothing but your qualitative data, right? So then you have the measurement data. So measurement data is what actually, it is actually a scale data. So your height is measurement data, your weight is measurement data, right? So your temperature is measurement data. So your oxygen levels are measurement data. Right? So that is what actually you are. So qualitative is this and the quantitative is this, right? So once again, categorical qualitative trait which you have, then it is called as the categorical data. So they are only labels or frequencies or whatever categories. So they are called as the categorical data. So for example, hair color, blondie, brown, red, black, etc. are the categorical data which you collected. Then opinion of students about rights, ticked off neutral and happy. So that is also a categorical data. Then smoking status is smoker and non-smoker. So this is called as the categorical data. And then so categorical data is being divided as nominal data and ordinal data. So nominal data is once again binary and not a binary. So now 1, 2 is binary. So it may not be binary also. 1, 2, 3 could be also there here. So coded values are 1, 2, 3. So then it is not a binary aspect here. So then ordinal data is actually binary. It could be. So that is important, not important. It will be binary. Then I say that here if it could be liking, disliking, and neutral. So liking is given a highest priority 3, and then neutral is given middle, that is 2, and not liking is 1. So it is given as least priority. So that is what actually is not a binary. It's a ternary. Ternary is being considered under this particular context here, right? So the next is, how do I define a nominal data? So there is no ordering. So I'm not giving preference to gender. So I'm not saying that your male is superior than female, or female is superior than male, right? So this sort of a unordered categories are coded in your questionnaire. So then that is called as what actually it is called as a unordered categories. And that unordered categories is called as the nominal data. So here, once again, the same blondie, brown, red, and black, no preferences here. So there is actually a simple, so I can as well say this is 5, 4, 3, 2, or it could be 1, 2, 3, 4. Anything I can as well. Similarly, race also Caucasian, African American, and Asian. So here also no preference. So it is given as 1, 2, 3 or 3 to 1. So whatever you want, you can as well do. So this is nominal data. In smoking status also no preference for smoker and non-smoker. So I just give 1 and 2. Suppose if I want to consider only the smoker, so then I just say that here preference is there. So I just give 2 as the smoker and then 1 as non-smoker. So the preference is for the smoker. So this could be ordinal under that particular context. So then you have the ordinal data. So this is nothing but a type of categorical data in which order is important. So that is actually fresh. Fresh is taken as 1. Sophomore is 2. Junior is 3. Senior is 4. Super senior is 5. So it's a 5-point Likert scale. So there is, I cannot take it as this as 5, 4, 3, 2, 1. Why I cannot take it a reverse ordering? I always take it as a 1, 2, 3, 4, 5. Why? Because suppose, see here, ordinal data, you can as well take the averages. Suppose if I just take it as this as 5, 4, 3, 2, 1. If the average turns out to be near about 5, so then I mean in that particular class, fresh people are more, and then super senior are around 1. Average will be around 1. So that sort of a wrong thing you should not do. So always in an ordinal data, the highest value will have a highest priority, and the least value will have a least priority. Suppose if you don't know the context of ordinal data, and then if you just give it as super senior is 1, this is 2, 3, 4, and 5. So then you have to mention that here I have taken fresh as 5 and super senior as 1. So then people will understand that here you have done a mistake there, and then that's the reason the super senior average is near about 1, right? So that is what actually the context with which the ordinal data has to be handled. Similarly here, degree of illness. So here also this is 1, 2, 3, 4, 5, and 6. So this is actually a 6-point Likert scale. I mean, this is how you just give the ordinal data is being decoded. So then here ticked off, neutral, and happy. Happy is 3, neutral is 2, and then ticked off is 1. So this is how you decode the ordinal data, because ordinal data, for ordinal data, you can as well calculate the averages, variation in variance, the standard deviation, you can as well calculate. For nominal data, you cannot calculate the average and standard deviation. So then what else I can as well calculate statistically? So the statistics which you can as well compute for nominal data is median, mode, and the chi-square test, right? So that is what actually we can as well do for this type of a situation where you have ordinal and nominal distinction. Right? So then binary data, as I told you that here, it could be a nominal or it could be an ordinal. So it could be 1 and then 2. If it is, it may not be binary, but it could be a ternary, and then as well as beyond ternary also, right? So that is what it says. So here, what are the binary data? Smoker, non-smoker, present, absent, lower classman, and upper classman. So this is how you can as well do the binary data distinction under this context here, right? So then the next is the measurement data. So measurement data is, it has got a quantitative trait. So this is a number. See here, I will tell you a confusion for the data analytics part when you do data collection, and then you are a researcher under a particular faculty. You just collect data, whether it is actually a secondary data or it could be a primary data. So whenever you have this type of data on hand, you feel that here 1, 2, 3, 4 is also numbers, and then 36, 46, and then our 5 feet 6 inches are 30 kgs or 30 pounds are also numbers. But you as an intelligent person should identify that here whether I am using a measurement data, whether it is I am using a scale data. So always the scale data, always a scale data will have what actually all scale data will have a unit measurement. So that is, it could be a interval data or it could be a ratio data. While in nominal data, there is no ratio and interval data. So that's the reason it is only a cases, number of cases, or it is actually a frequency. So then it is taken as what actually a discrete data. While measurement data, it is not the frequency or simply number, but it is actually a measurement data. That's the reason you just call as a measurement data. So measurement data is, for example, is cholesterol level, height, age, scholastic aptitude test score, number of students late for class, then time to complete a homework assignment. So these are all actually called as the measurement data. Right? So everything has got some scale measurement under this particular context here. So here, once again, measurement data is being divided into discrete and continuous. So you please concentrate here, what is discrete and what is continuous. So how do I define discrete? Can anyone give one example of discrete and continuous data in a day-to-day life situation? Anyone? Please unmute and then answer. Do you know what is discrete data? What is continuous data? You have seen it.
Yes.
Yes. What is the discrete data? What is continuous data? See here, discrete data is, zero. Yeah, someone has answered. Yeah, Saumiranjan Bhattacharya. Variation of temperature in a day is continuous. Okay. Number of students, age equals to continuous, correct? Yeah, yeah, correct. Number of students is discrete.
Yeah, that's what I said. Number of students is equal to discrete.
Yeah, amount of money earned today is discrete. Okay. So it's discrete. So money earned is discrete. Okay. So only for 1 hour you just earn and then say that here it is discrete. So the other hours you don't want to earn, right? So money is actually a continuous variable, right? So I'll tell you. So I'll tell you the distinction here. So how do I identify that here the data collected is actually a continuous data or a discrete data? Someone said the temperature. So that's a perfect example of a continuous data. Yes. And then earned today is actually a discrete data. See here, there are many examples. You can as well, very glaringly, you can as well define what is discrete and continuous. Like the number of suicides taken place in a month or in a year, in the whole world. So it is not continuous. Suicides are not continuous, right? Then the number of air accidents are not continuous. They are discrete. See, that means that actually a discrete random variable is the one which has got, which occurs with some gap. Like for example, if I just say 0 to 1, not necessarily at equal steps that 0 to 1 values should occur. So it could be 0, then 0.25, then it could be 0.75, there could be 0.76, there could be 0.8. So that gap. So whenever there is a gap, then I call that data as the discrete data. So while in a continuous situation, there is no gap at all. It continuously happens, right? So then I call that as a continuous data. So that is what actually we do. I'll just explain this with this particular thing here. Age is continuous, not discrete, Rajesh. Age is continuous. Right? Yeah. So this is, this is how we just see only certain values are possible. There are gaps between the possible values. So that's the reason it is called as a discrete measurement data.
So can we say if you can have a bijection between natural numbers or a subset of natural numbers, then that gives us discrete data.
No,
Otherwise,
natural numbers, subset of a natural numbers.
if you can have a one-to-one correspondence between
so
natural numbers or a subset of natural numbers, that gives you discrete.
Subset also could be. See here the behavior of the numbers there, not the set of numbers. So when you say that here it is these numbers, subset is what actually it could be a continuous, right? Or it could be natural numbers, could be many, right? So they are,
but still they are discrete.
Yeah.
Still
so,
they are discrete.
No. If you fix the range, then this will be discrete. If you fix,
that's right.
So I want to have natural numbers in 200 or 500. So then there is a gap from each natural number. Suppose if there is no distinction, then it will be continuously happening. Anyhow, so that in a mathematical perspective, you don't collect data, right? So this continuity and discreteness comes only with regard to the questionnaire data, or it could be a data which is collected by secondary means, secondary data. So there you have to identify whether the data which I am analyzing is it a discrete data or a continuous data. So if I distinguish this continuity and discreteness, then only I can as well employ a proper statistical tool. So if my distinction itself is wrong for a discrete data, discrete data is not normal in nature. Continuous data, it is normal in nature. So the number of suicides are not normal. They are abnormal, right? And then while if I just take it here, the ages of age of a particular this thing, right? It is continuous. Age of students in a particular class is continuous because there will be they'll be in terms of a months they'll be changing it, not exactly. So they are near normal. So ultimately that is what actually my interest under the continuity and discrete. But in mathematically speaking, if I want to have, as you say, Hassan has told that here, it is natural numbers. So natural numbers, I just specify between a particular range. If I just get it, they are discrete. If it is continuously, if I want to evaluate it, it will be definitely continuous data. So that is the distinction which you have to do. So this is what actually I was just talking. So visually, this is the gap I was just talking about. So the gap is here, it could be 0.5, it could be 0.25, 0.5, 0.75, and then 1. So the gap which is occurring here may not repeat in this particular gap, and in this particular gap, in this particular gap, in this particular gap. So this is when I just do this on this particular context. So I call that here, it is a discrete data. So while here continuous data, theoretically, no gaps between possible values, because so continuously it is happening. So that is the distinction which we do, right? So that is the distinction which you have to do it for getting the analytics done. Right? So examples is SAT scores, number of students late for class, number of crimes reported in a police station, and then a number of times the word number is used. So that is also, so generally discrete data are counts. So all the counts are which you take it as, so in a month, 2 suicides have been taken in a particular locality. So next month, it may not be 2 also, it could be no suicides at all. So there is a gap, so 0, the count is 0 there next month. So like that. So that is what actually you do that here. So the continuous data is cholesterol level, height, age, time to complete homework assignment. So these are all continuous data which are coming from a particular measurement. Right? So why this identification? This identification is that here is being used. The data collected should be analyzed for pattern evaluation. So how do I? What sort of a pattern it is? So what is the variation? What is the average value? Right? What is the correlation? Right? So is there any relationship between one dependent variable and many independent variables? Like a child's growth is dependent on the height, weight, and as well as the head circumference. So which variable is most influencing the child's growth? So this type of a situation has to be studied here. So then I just simply calculating height, average height, average weight, and average head circumference. So it really doesn't show the growth aspect. Right? So a particular reflective statistical measurement, if you just take it here, so that has to have all sorts of modalities and all sorts of properties it should consist. So therefore, for that reason, the identification of the data type is the backbone of analytics. If your identification is perfect, then definitely my analysis turns out to be perfectly done. Right? So that for that reason, we we have to do this here. So this most often people doesn't give preference. So a hands-on analyst or a data scientist or a data mining engineer has to undergo these specifications. Then only his analysis turns out to be a perfect analysis. Otherwise, it will be very bad. As I told you that here, they take it average of a nominal variable, variation in nominal variable, and then they correlate nominal variables. So, correlation cannot be done for a nominal variables. So you can do it. That is called as biserial correlation, right? But the quotient of correlation, Spearman's quotient of correlation, or Carl-Pearson's quotient of correlation cannot be done for the quantitative data. So for a qualitative data, biserial correlation can be done. And this biserial correlation is being done mostly by the education researchers. So B.Ed, M.Ed, PhD in education, those people do the biserial correlations, right? So that is the, they do all wrong things if you don't know the data type. So that is what actually the misconception comes with this particular data type. If you wrongly identify the data, then your analysis will be wrong. If you do it a perfect analytics, that means actually the the data type is being correctly identified by you, by the researcher. So this is simply nowadays no one is really going for percentages and proportions. That's the reason we just go for what is known as the averages. We start with averages, and averages means, averages are means, or then you just go for standard deviation, etc., etc. Right. So this is how you do that here. So this is my idea of data analysis. So a valid data analysis starts with a solid planning of the study. So that is, it is nothing but your questionnaire designing, then the reliability of that, right? Then a valid data analysis must have a valid set of data. So that is, it should have all sorts of mixed data. There is qualitative data, quantitative data. And then you say that here that this can be used for most of the statistical procedures, and then you'll be doing it a correct analysis of the above two steps are met. So then correct analysis can be done. So then the fourth step is that here you interpretation and results. Interpretation has to be properly done, and then you should conclude your experiment with a proper this thing here, right? So this is what actually. So now I just go back and then do the one hands-on this thing through the SPSS, right? So this is called as nowadays this is actually taken over by predictive analysis software. It is taken over by IBM. So it is the product name is still SPSS, but they have changed it to PASW. But now the sales is being done through SPSS only. So it is a IBM package. So this has got only 2 pages. As Excel has got umpteen number of pages. So this is 1 page indicates the data view, and this is your variable view. So here variable view, just see here how important even the package says here. See here, scale is measurement data, ordinal and nominal is qualitative data, right? So here, here the name, and here you can have number of variable types can be taken. So numeric, comma, dot, scientific notation, date, dollar, custom currency, string, etc. So this can be also, you can as well, this can be seen here. So that is what actually you have here. And then here, this is the decoding which we do. 1 is male and 2 is, here value, just give it and then label this thing here. So that is how you do that here. And then here also, you just take it, 1 is arts, 2 is science, 3 is medicine, and okay. So this is how you can as well do that. And then this is the labeling of this thing. So that is normally the question. So you say age in years of attendee is being given, faculty of attendee, attendee status, and weight in kgs, and heights in meters, etc. So this is the thing which you have here. So what sort of a data it is? Yeah, what sort of a data it is? So can you, can you just take it as this thing here? So this is cases. So there are 343 cases, and this is age, gender, faculty, status, stones, pounds, kilos, feet, inches, meters, smoker, number of cigarettes per day. So this is what actually given. So here, if you just see this here, age is actually a continuous variable, and then gender is actually a discrete data. So this is qualitative data. Then faculty is also qualitative data. Status is also qualitative data. Then stones is actually, it is actually a continuous data. Pounds is also continuous data. Kilos, feet, inches, etc. Right. So what analysis I can as well do that here. So I just show it. So here I say descriptive statistics. So I say descriptives. So I just take it age. I just take it because it's a continuous variable. I can as well calculate what is the average age. Then I say that here I just variance, standard error of mean, range, kurtosis, skewness, right? So this I just want to calculate here. So I'll say, okay. So I got it here. So there are 332 cases. Minimum is 20 age, and then 57 years is maximum. So average age is 31.08 and standard error is 0.41. And then here standard deviation is 7.47, right? And then variation is 55. So that means that actually the people are between 20 and 57 in my sample. So the variation is quite high, right? So that's what actually I can as well comment on this here. So here it is skewness is not 0. So definitely the data is not symmetric. It is asymmetric. It is more skewed, right? So kurtosis is also, it should be 3, but it is very less. So it is very skewed distribution which you have. It is not normal data, right? So that is how I just got it here. Now, after doing this here, so then, I just take this particular data and then I do one more thing here. So I just go to, I just calculate the cross tabs, right? So I take it, gender is rows, then faculty of attendee, and as well as attendee status, I just take it here. So this is actually, I'm doing a cross tabulation. So this is, I just do a display of cluster bar charts. So then I say statistics. So I just calculate the chi-squares. So then I say continue. Then I just take it, the expected frequencies, continue. Then I say that here it is okay. So I just got it here. So I just got the cross tabulation done. It's running. So it's running, and then now so there are 332 cases. So it should come fast. Okay, I'll do that here once again. I'll just go to analyze, descriptive statistics, cross tabs. So then I say, okay. Yeah, so now I got it here. So this is my case processing summary. So I just take this here. Males, there are 53 males are there. Their expected count is 48.9. Why I have just calculated is the chi-square is sum of OI minus EI whole square by EI, which is the goodness of fit here, right? So I just say that here, what is my null hypothesis? I'll tell you in the next class, right? So I just say that here, there is no gender disparity with regard to the people joining in arts, science, and medicine. So that is my null. That is my definite statement regarding the population parameter. So in any university, there is no disparity of male, female joining the courses. That is my null, versus there is actually this thing. Alternative is there is a change. So I just calculated the chi-square 4.583, and then this is 2 degrees of freedom. So there are, you have 2 rows, 2 minus 1 is 1, and then there are 3 minus 1 is 2. 2 into 1 is 2 degrees of freedom. So it is this is the probability value. So this probability value should be less than 0.05, which is greater than 0.05. So that means that actually male and female are equally distributed in art, science, and medicine. That is the conclusion I can as well make it from this particular case here, right? Then next is, this is how I just do. This is my cluster bar chart. So male distribution is this, blue is arts, green is science, and this ash color is medicine. So this is how you just get the male. And then here also you get the female, right? So now, similarly, I just go for the other, this thing, gender versus attendee status. And then this p-value turns out to be 0.024. So that means that actually attendee status, so that is people who are joining undergrad, MSc postgrad, PhD postgrad and others, there is a significant difference in the count of male and females. So there is a difference in this. So here null hypothesis is not accepted, but alternative hypothesis is being accepted. So that is the context with which we just do the analytics here. So here, so this is actually chi-square is exclusively for discrete data. And then in the previous descriptive statistics, it is exclusively continuous data. So now, after this, I just say that I want to go for a combination of categorical versus continuous data. So for that, I just go to descriptive statistics, then explore. So I just take it gender as my factor list, and then age is my dependent list, which is continuous data, right? So I just do the plots, so that is histogram. Then I say, yeah, normality plots with tests, right? So then, I say statistics. So descriptive statistics. So then stem and leaf I have just given here, continue. So then I say, okay. Right. So here, see here, this is continuous data. For this, mean is calculated, median is calculated, variance is calculated, standard deviation is calculated, right? So then, see, this is actually, this is actually a skewed data. This is not normal. Why? Mean should be 0 and then variance should be 1. So this is greater than 0 and then greater than 1. So hence, this is male data is not normal, it is abnormal. So here also it is the same. So they are abnormal, abnormality, asymmetry is being seen here, right? So now I just calculate this particular thing. This is not, these are the various statistics. This is called quantile plot. So here is just here, that's the reason, see here, this is my fitted line and these are the observed values. So which are beyond this, the fitted line. So hence it is not normal in nature. And similarly, this is for the female. Female also there is a lot of variation in the observed values. So this is actually quantile plot for the observed to the expected values here, right? So then I just go to this thing. So this is what actually is called as the box plot or stem and leaf. So here, so these are the leaves. These leaves are the variation among male, and then this is the dark line is the median, and this is the variation below this particular stem, and then this is for females. So there is a lot of variation among these things here. So there are more than 30 median age people are more here in this particular males, and then here it is also the same way. So below it is very less, below 30 years of age in males are very less, but here it is almost equal in this particular female situation. So that is what actually we can as well do that here. So this is called as the visualization, right? So now, there are various visualizations which you can as well do that here. So I'll just start the next topic which I have given it for today, and that is the statistical visualization for the data which you do. So the slices, how do I generate? How do I do these box plot aspects? So what does this box plot, any of you have seen it here. So this can be done for any number of, this is a combination of what? Categorical data on the x-axis, and then on the y-axis, it is a continuous data. So whenever you have a possibility of this sort of a mix and match, that is categorical and as well as continuous, you can as well study this sort of a analytics under this. Right? So this is how, so you can as well do many things under this particular case of the data this year, right? So I'll just go to the other aspect here. So I just go to the, other this thing. So this is what actually is called as exploratory data analysis. Share. Yes. Yeah, so this is EDA, so that is called as exploratory data analysis and data visualization, and this can be achieved nowadays. Python. Python is actually a new this thing, so which has got a high amount of these visualization techniques. So slices you can have in n dimensions. You can as well get the data, seen how the behavior of these data, etc., etc. So because of this AI. Artificial intelligence. So this data sciences approaches with regard to the visualization is really very much interested to the researchers and as well as to the analysts. So that is what actually their interest. So EDA is EDA exploratory data analysis can be done in terms of what actually, so which variables are influencing to buy a flat or to buy a house, and then or any other things here. So like, for example, if you just take it air data, so which one is in air, which component is more concentrated in polluting the air pollution, then water pollution, then water hardness, then many things here. So which political party comes into the post. So actually me and my student, we were analyzing data recently and see the visualization between the speeches of Biden and as well as Trump. So what is that actually Trump is concentrating? What is the topics he is concentrating in his speeches for his election? And then Biden. So we have got that here. So Biden was talking more on immigration and as well as more on job potential to the citizens of America, while this guy is not talking anything about other things here. So this is what actually one of my student and me, we were doing a project on this particular thing, and here it is no data. So the data is only the speeches. So this is actually comes under natural language processing, NLP, right? So we want to analyze this particular speeches and then get the topic modeled, and then what are the keywords. Depending on the keywords, we can as well do. And one of my other student also has done the 60 episodes of Honorable Prime Minister Narendra Modi, and then we have analyzed and then seen that here, what is that actually the 60 episodes right from his PM as PM of India, what is that things he was concentrating on these speeches of Man Ki Baat. So that also we have analyzed, and then we found that here very glaring important topics are being not considered at all in his speeches here. And then there are certain words that are expected, so those are being used mostly. Right? So that is what actually we can as well do under these exploratory data analysis and data visualizations. Right? So here, as I told you that here, EDA can be having one variable visualization, so that is only height, two variables, height and weight, more than two variables, height, weight, cholesterol level, blood pressure level. You say that here, a candidate's prospects in a particular constituency. So village number one, what is his this thing? Village number two, what is his prospects? So you can as well combine all these things into a cluster bar chart and then see that here what is his prospect. And then or else you can as well take it as a pie diagram and then see that here what could be the chances of his winning as per the preliminary data collected or survey. So that sort of a thing you can as well do more than two variables. Then other types of data. So other types of data, there are many like scientific data, etc. Or you can as well say that here it is other types of data is snapshot data. And then the performance of a government in exclusively in terms of yes, no, every quarter, the police department will get the answers taken from the citizens and then see the performance of the government in each and every district or in each and every state. So this is the other types of data, which is snapshot data. It is called as word to mouth data. So there are many types of data you have here. So that that can be visualized here. Then dimension reduction. So this is the most important aspect of multivariate statistics, and that also I'll be just taking care of in the last day, multivariate data analysis 1 and 2. So there I'll be talking about the dimension reduction, right? So how do I reduce the dimensions? Like, for example, you just take a snapshot and then from your smartphone or from your camera. So you just get it. So this will be converted into a mathematical form called as the Fourier transform. And then this has to be Fourier transform. It takes so much of space in your phone and as well as in the camera. So that has to be reduced into a smaller dimension. And then if I want to retrieve it, I can as well retrieve the smaller dimension and then take without loss. I can as well retrieve the whole image with less data. So that is called as the dimension reduction. So which we can as well study all these things under these visualizations. So this is actually a very important aspect because the data sciences has been given a lot of importance these days in this particular century. So actually this importance has come whether the data which I am handling is actually a symmetric data or asymmetric data or skewed data. That is what actually we want to study. So then we say that here, also we want to see the quality of the problems. Then is there any outliers are there in the data? Then is there any relationship between the variables which I'm just taking it, or there is no relationship at all? They are becoming independent. So, or there is some sort of a dependency. So then you just go for the subsets of interest. Then you see the functional relationship. So suppose if I say y equals to ft has got what actually it is, this function has got the time related thing. So I have a trend, time trend I have. Then in time itself, I can as well get the seasonality. I can as well get a circular trend. So like, for example, if you say the sales of a supermarket, first fortnight, the sales will be booming. Then next fortnight, it will be down. So that sort of a relationship, can I see it in a supermarket? So these are the various aspects you can as well do. And then the achievement of these various problems can be achieved by the EDA. So that is the exploratory data analysis. So you are exploring all sorts of a data in terms of a visualization, right? So this is exactly this. So this is a data visualization like a cake bakery. So here thin mints are 25%, and then peanut butter is sandwich, etc. So these are the percentage of this thing sales is seen in the bakery, right? So then, here, all these things are all actually what actually you have to, as I told you that here, the data which you have collected. So what sort of a visualizations I can as well do? What sort of a proper visualizations? Like, for example, I say that gender versus, in the previous hands-on experience, I've shown it. So that is gender versus the faculty of attending. So then, so this is not actually a single table or a single column which I can get it here. I get multiple variables are taken and then see that here how best they can be shown it in visualization. So therefore, I've just taken actually on the x-axis, I've taken the gender. On the y-axis, I've taken the faculty of attendee, right? So they are science, medicine, etc. So those are the faculty of attendees. So they can be taken as histograms, box plots. Box plots also I have shown it here. So then means, medians I have calculated and quantiles, etc. So these are the things which you can as well see in the data. And then these are all actually what actually data driven. Without any data, you cannot actually get all these things done here. So necessarily, so these visualizations are mostly done for what actually it is a combination of qualitative data and quantitative data, or exclusively the qualitative data, but not with the quantitative data. So quantitative data, if it is exclusively quantitative data is there, so that quantitative data has to be converted into categories. So that is also possible in the SPSS. So you just convert the continuous data into categories and then draw the histograms or cluster bar charts or the pie diagrams, etc. So those can also be done here. So, and also see that here, is there any outlier? What is an outlier? Outlier is nothing but an extreme value. Like for example, if you take it insurance data, right? So insurance data, normally what actually very rare people will get a premium. That is a claim. Claim is greater than 5 lakhs or greater than 10 lakhs. So they'll be counted on fingers. There are very few people will be there. So that will be an outlier on that particular year under that particular data set. So that is what actually the detection of the outliers. So you want to see that here, how many are there? More than 5 lakhs claim under the insurance facility, right? So then for every data which you collect has to have certain assumptions, and that assumption is nothing but the normal distribution. So if it is a bell-shaped curve, it is the data which is collected is normally distributed, because all the tests has to be followed by the normality assumption. So if normality assumptions are failed, definitely it doesn't give you a proper statistical analysis for the data. So we assume that here it is normally distributed, and it is not skewed, but it is symmetric, and it is not asymmetric. Then you cannot apply a particular statistical tool. So right. So suppose if you find your data is skewed, so then that can also be converted into a symmetricity. So how do I do that here? I just X is my weights, right? So weights are not normally distributed. So then this weights can be converted into take the weights average, take the standard deviation sigma. So then convert this X to Z equals to X minus mu by sigma. So that will be a normal distribution. So now I just plot normal distribution for Z, not for X. X is skewed. So Z will be now normally distributed. Now I do the analysis using Z, not with X. So that is what actually we do under the test assumptions. So identify useful raw data and transform. You can as well convert it to a square root transformation, or you can convert it to a log transformation. Right? So our square transformation, suppose if X is there, you take it X square will be normally distributed. So that is what actually we do that here. So therefore, definitely whatever you see with the data, so the data will be having lot of worthiness can be seen if you analyze properly the data set. So this is a summary of these particular things are taken into this thing here. They are not visual, then definitely you have to calculate the averages, variances, then first and third quartiles, and then fourth quartiles, range, interquartile ranges, then variances and skewness. So this is actually negatively skewed, right? This is positively skewed. So this is positively skewed and this is negatively skewed. This sort of a data, you will be definitely handling it when you just go for analysis here. Right? Then histograms. So histograms is that here. So histograms are used to see that here whether there is actually some sort of a variability in the data. Then they are skewed or they are symmetric can be seen. So then if it is skewed, mean median mode doesn't fall at the same point here. So here you just see here mean will be somewhere, median will be somewhere, mode will be somewhere. So that sort of a, you can as well see for asymmetric data. So you avoid all zeros here. So zeros cannot be considered into the this visualizations. So there will be a lot of danger will occur in this particular this thing here. So this is what actually histogram of diastolic BP and histogram of a diastolic BP. So this is our this is also diastolic BP. See here. So this seemed to be, if I just ignore this, so this seemed to be normal in nature, but this is not normal. So this is negatively skewed, and this is positively skewed, right? So this is how you can see that here. So for a smaller data set, histograms will be misleading because why? A smaller data set, it won't come into a proper aspect. So hence, definitely it will be a misleading this thing here. But larger data set, it can be histograms will be quite effective. Right? And then they give you whether larger data set, the data which is considered by you or collected by you, is it actually having a normality assumption or not, right? So then histograms are effectively only work with one variable at a time, but small multiples can be effective. So histograms of one particular thing variable only can say multiple groups. You have to go for a clustered bar chart. So this is what actually. So, but be careful with access and scales. So this is what actually the various histogram types I have just shown it here. Scenario 1 and scenario 2, and then this is NR, R2, etc. So this is this is the normality assumption, but here there are many points here. So this is more skewed. This is normal in nature, right? So this is also not normal. This is not normal because so this is actually more skewed here. So this is seem to be normal in nature. So that is how you distinguish the visualization of the data. So then you have a smoothed histograms. That is, you just take a density function. What is a density function? Suppose if I say that here, 1 by sigma root 2 pi e power minus half of x minus mu by sigma whole square. So this is normal. So the densities are also done. So this is actually a bivariate normal. So this is one normal and this is another normal. So this is how you just do, and that is called as actually a Gaussian distribution, right? So that is how smoothed histograms for the density functions. So that is all the data represents a function, right? So like for example, the function is theta e power minus theta x. This is actually an exponential distribution. So that also can be plotted. That's what actually it is. So for different values of x, and for a fixed parameter theta, you can as well draw the density function. Right? So then bandwidth choice is an art. So this is the bandwidth, how the continuous data. So nowadays, when people are using streaming data, so when the production is on, you will get the quality you want to know immediately. You don't want to wait for some time and take a sample and then analyze that here. So that is actually, this is called as bandwidth data. So like your ECG is bandwidth data, your EEG is also a bandwidth data medically. So this is what actually we do under the visualization of this here. So just now I told you, this is the box plot. So this dark line is actually the median. So these are the two, leaves, and this indicates the variation. So these dots are the outliers which you have seen here. So that is, so these are the things here. Median is this. Then interquartile range, you can get it. Outliers are this. Then range also you can get it. Minimum and maximum. Skewness is that here, whether it is symmetric or asymmetric, you can as well calculate here. So this is what actually you can as well do under the box plot, which I have already shown it here, right? So then this is what actually, if your data is temporal component, be sure to exploit it here. So this is how you can as well yes, here you can exploit this, and this is the line diagram, right? So mean weight versus mean age for 10K control group. So this is how it is. So it is going in a stepwise this thing here to reach. So age and weight, how the as age increases, how the weight behaves. So as age increases, weight is also increasing. So that means that actually definitely data is normal in nature, and then as age advances, definitely weight also is being increased. That's what actually you can say with this particular visualization. So these are the 20,000 kids 5-year raw, and then so this is the data where from we got it, Scotland. Sorry. So this is the unexpected pattern steps. That is actually the steps are being seen here, and then not appear from a raw data table. So this is actually as that's what actually I said. As age increases, weight also is increasing. So as height increases, uniformly weight also increases. So that's kids weighed in clothes, summer graph lighter than the winter. So that's actually we have here, right? So this is actually a spatial graph. So if your data has a geographic component, so then you can as well exploit by the scatter plot. So this is how you just get the scatter plot done here. So this is one cluster and this is another cluster. Normally, if you just take it, Hassan will be interested more in star clusters or black holes among the clusters. So those type of this thing you can as well see just by plotting it. So this is the spatial maps. Geographically, you want to know that here, which is the seismic region and which is not a seismic region, right? So all these things are can be got. You must be wondering, he's telling so many things, but how do I get these data given? How do I get these visualizations done? So you can either do it in R, you can do it in Python, or you can do it in SPSS, as you have seen it here, or you can do a Statistica. You can as well write a code in C, C++, anything. So all these things can come. You don't want to waste time. You can as well do it with the SPSS or Minitab or your Python. So Python is just read the data, input, output, and then give a subroutine of that particular visualization, and then you'll get it the things evaluated. Right? So for mathematical function, you just go for a Mathematica. Even MATLAB gives you these visualizations perfectly, right? But you have to write a program in MATLAB. While Python also a very small code, it's pretty easy. So if you just learn for 2-3 days, you can as well able to handle your data set properly. So this is two-dimensional. So this is one two numeric variables. This is one, and then scatter plot in between. So this is one particular testing here. So these two. So this is the data which is actually following some sort of a linearity in the data. So this is total bill, and this is what actually total. This is total tips. So that is what actually you have here. So this is the scatter plot of the obvious choice, and then you want to say that here. So nothing is many. If you just compare this hexagon to this hexagon, so definitely here more points are being seen here. Here it is very less points are seen here, but the data which is really showing up some sort of a linearity, the scatter plot. So that is what actually you can as well know here. So then next is this is the other aspect here. Relation between two variables. So whether they are really useful or becoming independent. In this particular cases, they are becoming independent, or whether it is linear or quadratic or other. So variance of y and variance of x, are they differing? That can also be seen under this particular context of the comparison of two, two populations or two samples, and say that yeah, they are linearly related, or they become independent, quadratic, or other aspects of the data can be studied under this visualization. So this is the scatter plot. So here they are all independent here. So nothing is formulating into a parabola, or it is actually a power curve, or it is actually this thing. So everything is independent. Here there is no correlation at all. So here, if you just plot it here, it is a line like this. Right? So that is what actually the scatter plot of this here. So this is negatively correlated. So as x increases, y is as x increases, as x decreases, y is increasing. So that sort of a thing, negative aspect is being seen under this particular context. X is increasing, and then y is having a decrease this thing here. So a negative relationship is being seen. So this is the fitted line, and these points are the observed points here. So this is called as y equals to a plus bx. Under principles of least squares, you can as a fit here. So y is your data set, x is another data set, a and b are, a is the intercept, b is your slope. You estimate a and b, right? A and b, and then fit this particular line. So negative aspects are being seen in this scatter plot. So this is actually a curve linear. So this is not linear. So this is actually a curve linear scatter plot is seen here, right? So this is actually a leverage point. So yes. So this is actually, yes. So this is the other scatter plot where the many leverage points are there, and then so it is not increasing by this time. So they concentrate only in this particular region. So this is the various visualizations which you can see data collected. So this visualizations, unless and until you know that here, you cannot really interpret your data and then come to conclusions here. So for that reason, visualizations have become very important tool in statistical analysis here. So this is actually so this is here the leverage points are almost near to these two lines. As it proceeds, so this is the difference is quite high. So this is a variation in y differs depending on the value of x, and y annual tax paid is y, and then x is the income. So as income is increasing, the annual tax paid is also being increasing. So this sort of a scatter plots can be seen under visualization aspect. Right? So this is, I mean, this is actually a very bad fit. So because it really doesn't show any visualization aspect. So this is actually a cluster which is having, so all the values are near about to each other. So the distances are not much. So hence it turns out to be a very bad scatter plot under this particular context of data analyzed. Right. So this is contour plots. Contour plots are mostly used in science approaches like seismic data or your I mean remote sensing data, right? So there you just go for these contour plots. Contour plots are very good, visualization techniques are being contours are there in MATLAB and as well as in Mathematica and as well as in your Python, right? R also is there, but not that powerful as Python, right? That is what actually the contour plots which you do visually. Right? So this is I mean this is another temporal plotting here. So you can as well say that here how this thing is. So here distance is almost 0. So when you just take from middle to this particular point, if you just go to, the distance is quite high. So how concentrated the data is being studied here, right? So this is the I mean which we do that. So then this is a jittering plot. So how the data is initially, and then as time progresses, so then what is actually uniqueness is being achieved in this. So this is called as actually jittering points. This helps mostly in medical data. So age is being as age advances, then the times pregnant will be taken into consideration. So this is displaying of two means, right? Or two variables how this thing is being taken. So these are the true histogram, and then this is the false histogram, right? Diastolic blood pressure. So many software packages have implemented this. So and this is only a simple this thing how the two variables are behaving. I mean, in terms of a small multiples of the data. So that can also be seen here, right? So this is what actually I've just shown it in the data which I have taken. So this is actually two factors, and on the y-axis you have continuous data. On the x-axis you have the factor data. So here it is I mean Friday, Saturday, Sunday, and Tuesday, Thursday. So how the sales are being differing. So that is various groups on the factors on the x-axis, and then y-axis is your continuous data. You take it here. So it's a combination of continuous and as well as the categorical. So continuous on the y-axis, categorical on the x-axis. So whenever you have this sort of a thing, you can as well plot a you can as well go for a stem and leaf or box plot. They're both the same. So this is actually a bar. I mean within bars the section. So even this you have in your Excel. So these visualizations you can as well see it in. This is called as a spline plot, and this is called stacked plot. Stacked bar charts. So all the three charts you can have it in MS Excel. And this is actually pairwise scatter plots. So this you don't get it in MS Excel, but you will get it in Statistica or SPSS, your Python, and R also you can as well get it here. So why you just go this for these pairwise scatter plots? You want to know that here each one of these variables, how they are behaving. So that's what actually I told you. So that your visualizations really gives you a lot of insight of the data. So how see like for example, if I just take it this particular this thing, so it is linear. So if I just take it this particular variable, it is not linear. So it is only concentrating here in this particular variable. So this is what actually I mean whether your categorical data is effective or not effective can also be seen under this particular context of the pairwise scatter plots. So that is you want to see that here how best the pattern is being seen for each one of these variables here, right? So whether I mean they are concentrated at one particular thing. So this is linear. This is also linear, right? So here it is concentrated in this thing. So you say these two variables seem to be the same in these pairs. So this particular 6 variables seem to be the same. That's what actually you can as well do that by this particular scatter plots. So this is another this thing here. So how normal the data is. So once again here, these are the variables, and then the same thing. So for these variables, you just see that here whether there is the data is univariate. So here it is almost univariate. So here it is seem to be binormal, bivariate normal. So that is how you do that here. So this is I mean curve linear or a straight line of both the data sets is being seen. So cancer is in pink and then blue is in normal. So normal patients are this here. So here I mean seem to be normal. The behavior of normal patients to the cancer patients, there seem to be a lot of variation. That's what actually you can as well see under this particular context of this thing here. Right? So then you have multivariate. So earthquake data and then conditioning of one variable over the other. So that can also be done by the visualizations. So this is the I mean various other aspects. How the like for example depth. See earthquake happens with the magnitude, latitude, and the depth. So all the three, how the behavior of the earthquake can also be seen in this different plates. So this is one plate. So this is exclusively depth. And this is depth, and then this is a longitude, latitude. You can also see here. This is latitude, and this is longitude, and then how the depth is behaving with regard to the So this is the same way. So with various pairs, longitude, latitude, and etc. So this is what actually you have a 3D dimension. So these are also you can as well get it in MS Excel. So this is another 3-dimensional aspect here. So with the ribbon aspects, worst how the bind this thing frequency data is being done is being seen here. So this is in 3D. So 2 and 3 dimensions also you can as well do that here. Variable selection, principal components, and multi-dimensional scaling. All those things you can as well do that by this year. So this is this thing you can as well see this year. This can be very useful for visualization, various aspects of the data. Right? So if you have any doubts or clarifications, you can as well do that here. See, all visualizations may not be really useful, but what I say is that here, if you have many variables, so then visualizations are all possible. That's what actually my ultimate goal in this particular context here. Because with visualizations, you can as well come to a conclusion that here how the data is behaving, whether it is linear, non-linear, or curvilinear, or whether it is independent or dependent. So all those the aspects can be studied with the exploratory data analysis. So for that particular context, I've just taken this as one particular aspect here. Because if I just take it data type, so directly I'm not going for the computation. Computations will be taken into tomorrow onwards by just taking as the testing of hypothesis. So that is you just go for estimation. You want to estimate, and then you want to go for the testing aspect. So what is actually a small sample? What is actually a large sample? So how do I analyze this data? So those are the things which I just take up next. So this is actually a preliminary aspects of data analytics here. If you have any questions, I can as well answer. Otherwise, I'm done. Asad.
Thank you, Professor Hargopal. It was an excellent talk. And if there are any questions from participants, please ask in the chat window or unmute and you can ask.
Yeah.
Professor Hargopal will be giving another 4 lectures.
Yeah.
He was kind enough to cover the
From
whole
univariate to multivariate handling, I'll be just talking it.
Yeah. So one has to realize that it is statistics has become essential in research these days in all areas. Maybe there could be some areas in mathematics where they may not be using statistics, but in applied maths, in physics, in life sciences, chemistry, it has become extremely essential. You send any paper, they ask you for the statistical uh, uh, backing for that. So the inferences you make, you have to support it with statistics. And Professor Hargopal gave an excellent talk today, the first one where it's very important when you start with your actual collection of data, you have to be careful in designing your questionnaires, your database, because later you are lost. You can't do anything. So you start off with statistics. You have to speak to a statistician and decide how are you going to collect data, what are the different data types, how to tabulate it, and then you can do all kinds of wonderful things with this. So thank you, Professor Hargopal. Let's see if there are questions. Otherwise, they can ask questions. You'll be with us for many more sessions, so they can ask questions then.
Yeah, someone.
And a word.
Yeah. Okay. That's all.
Excellent session, says Mr. Mahesh Jamdar, and Dr. Santosh also says, thank you, sir.
Yeah.
You have given very important information.
Yeah.
So if there are no questions, we'll stop the session now.
Yeah.
I thank Professor Gopal on behalf of everyone in the meeting. Thank you. Thank you. See you tomorrow. Stop.